Greetings, math fans. Alright, so this is a note sheet that you guys should have. I'll pass out in class, but I'm just going to go over these 6 different types of problems. And our topic today is called optimization. Okay, so when you're optimizing something, you're either trying to maximize something, and sometimes you'll like maximize profit, or you're maximizing volume, or you could be minimizing. You could be minimizing cost, or you could be minimizing surface area, right? When you're trying to build a box, you want to minimize surface area, but you want to maximize volume because you want to use the least amount of material and you want to hold the most amount of material. Okay, so these are, again, just different types of problems, so let's go through this. All right, so first problem is the sum of two non-negative numbers is 120, and the product of one and the square of the other is a maximum. Okay, so again, different things we're looking for, maximum. So obviously when we do our interval testing, we're looking for something that's a maximum. It says find the numbers and the maximum product. So basically what we have here is it says sum of two non-negative numbers. So we're going to do x plus y is equal to 120. Okay, and then the product of one. So we'll just say x is one of them. Doesn't really matter. X and the square of the other. So times y squared is equal to maximum, and we'll call it a function. I don't know, just call it p of x. Okay, it doesn't really matter. Okay, and then what we're doing here is, well, we have two equations, and we can just do a system of equations. Well, I have to solve first here for one of the variables, so I think it's a little bit easier. I could solve for y, but think about it. If I solve for y, then I'm going to have to square that and FOIL it. It does work out, but let's just be reasonable and solve for the simplest one. So I'm going to solve for x. So I get x equals 120 minus y. Okay, and then I just substitute that into our x right here. And so I have p of x is equal to 120 minus y times y squared. So p of x is equal to negative y cubed, I'm going to put in descending order, plus 120y squared. All right, and then of course we take our derivative to find our critical values. So p prime of x equals negative 3y squared plus 240y. I'm going to set that equal to 0, and I can factor out negative 3y here times y minus 80 equals 0. So I get y is equal to 0 and y is equal to 80. All right. Which one don't I test? Okay. Well, actually, I test both of them. It says sum of two non-negative numbers, right? And 0 is a non-negative number, 80 is a non-negative number. So I really need to kind of check both things here. Though I want you guys to understand that 0 is what? Isn't 0 an endpoint? Okay. 0 is definitely an endpoint. And guys, I am going to put on top here because I think it's really important. You need to test endpoints a lot when you're doing all these different types of problems. Okay, you've got to check endpoints. Really, really, really important. Okay, so first of all, I don't need to check 0 as in my interval testing, do I? Because it is an endpoint, and it can't be a relative extreme at an endpoint. So I'm just going to test the 80 here, and 79 and 81. And again, I plug that back into my derivative equation, and I see it's plus and then minus. And of course, you take your hand, you go plus, and you go minus, and you know it's a maximum point. So that's always very nice. All right, so what I need to do here is I need to test, this is, again, it's closed interval. The reason it's closed interval is because you can test your endpoints, right? You have an endpoint, which actually is 0. So here we go. We're going to test p of 0. I'm going to test p of our value, 80, because I want to see if that's truly a maximum, absolute max. And what else are you going to test? Do you guys agree? I'm also going to test p of 120, because that's the other endpoint, right? Because the sum of two non-negative numbers is 120. So the smallest it can be is 0, the biggest it can be is 120, and then I'm testing the 80 in there. Anyway, if I take these and, of course, plug it back into the original equation, I get 0, because it's the product of one and the square of the other, right? So, that's, and you just plug it in here anyway, and you see it's 0. And if I plug the 80 in there, I get 256,000. And I plug the 120 in there, and I also get 0. All right. So you need to show all this information. If you do not show this, I mean, it's great to get the answer right, and probably most of you would have said, well, duh, it's pretty easy that you're not going to plug in 0, 120, but you have to show it in order to get full credit, because it is truly an endpoint, and you have to show all your work. Okay. So the final answer to this problem then is 80, and of course this is y, right? You guys agree with that? This is the value of y. Not that it matters which one's x and which one's y, but then when we plug it back into this guy right here to find x, we get x equals 120 minus 80, which is 40. So my numbers for my answer are 80 and 40, and then they ask you for the max product, which of course is just 80 times, or the max is the plugging it into x times y squared. So it's 40 times 80 squared, right? And that gives us 256,000, which we already figured out right here. Okay, so that's our answer to that problem. All right, so that's the first one. That's a pretty basic one. That's just using numbers, but let's actually get to a little application here, which I think is kind of interesting. Okay, an open box is made from a 3-foot by 8-foot sheet of metal by cutting the squares of equal size from the 4 corners and bending up the sides. Find the maximum, okay, keyword, find the maximum value that the box can have. So let me just sketch a quick picture here of what this is going to look like. So here's your rectangular sheet, and this is 3 by 8. And you're cutting off squares in the corners, so we're going to, here's your squares, because then you're going to fold it up, right, to make a box. And we don't know this, so we're going to call each of these guys x. All right? And do you guys agree that this guy right here, this spot there, which is actually going to be the length of the box, right? When we fold that up, that's going to be the true length. Isn't that going to be 8 minus 2x? And this guy right here, it's going to be 3 minus 2x. That's 3 minus 2x, okay? And so let's take a look. We're trying to maximize the volume. So let's write out our equation. Volume is equal to length times width times height. All right? Well, let's put this all, of course, in terms of our letters and numbers that we have here. So the length of the box, you guys agree it's going to be 8 minus 2x. The width of the box is 3 minus 2x. And the height of the box is x, because that's what happens when you fold it up, right? Times x. Okay? All right, so, and we're trying to maximize this. It's kind of a nice problem, right? Basically what I can do is I'm just going to kind of put everything together. I mean, you could do the, the product rule. That's brutal, actually. You really want to put this all together here. And if I do multiply it all together, well, here I can do a little bit of work. But that's FOIL. So we get 24 minus 22x plus 4x squared times x. And so volume is equal to, putting it in descending order, 4x cubed minus 22x squared plus 24x. Okay? And so v prime, I'll call this v prime of x because it's truly in terms of x. Okay? So v prime of x is equal to 12x squared minus 44x plus 24. And I set it equal to 0. Okay, and then we factor that, and then actually factors kind of nicely to, I'm doing this a little ahead of time because I don't want to waste my time in factoring, but it's 3x minus 2 and x minus 3 and equals 0, so we get x is equal to 2/3 and x equals 3. Now, I want you to take a look at this one, math fans. What's wrong with that one? Okay, well, think about it. This is 3 minus 2x. It's impossible, right? You can't have 3 minus 6, right? It doesn't. You can't have a negative dimension. So this one's actually out of there because this one's impossible. So my answer to this guy is going to be 2/3. So what I need to do is, let's do it over here. This is 2/3. I need to do interval testing. Always have to do that. Okay, and I'm going to plug in, I can do 0 and 1 here, and I get a positive to a negative, which of course you realize then this is a max. All right, and then I want to find my volume, and I'm going to say so V of 2/3. It's plugging it into the original equation. That gives me, simplifying it, 200 over 27, which is 7 and 11/27 cubic feet. All right, so that's my answer. Now, some of you guys are saying, wait a second, Mr. Curvis, you've totally stressed interval testing, or testing your endpoints, and you have not done that. Okay, and my answer to you is, this is an open interval for this problem. And why is it an open interval? Because think about it. Can a dimension of a box be 0? No, but can it be 0.000001? Yeah, it can. So in other words, since it's an open interval, I have no endpoint to test, so I don't have to worry about testing that endpoint. All right. A lot of problems you do have an endpoint, like that first one we did, and there are several other problems where you can have a 0 for even like profit, where you make 0 items. But in this case here, it's an open interval because you can't have a dimension that's 0. Okay, so that is that's my answer. All right, let's go on to the next one here. A rectangle is bounded by the x and y axes, and the graph of y equals 6 minus x over 2. See the of course, look at the figure there. Determine the length and width of the rectangle so that its area is a maximum. All right, so we have our nice little friendly equation. We're going to call this our area equation. Area equals length times width. All right, and if I look at as opposed to using L and W, I'm going to use X and Y. So really, A of X equals, I'm going to call my length, of course, my X value, and my width, the height of that, is Y value. Okay, it's pretty easy. And I have a nice little equation here. Y is equal to 6 minus x over 2, and I'm going to plug that right into there. So I get my area in terms of just x, because I want one variable, right? I want to be able to take the derivative and just have one variable in here, and that's why we have the substitution. So area is equal to x times 6 minus x over 2. So my area, I can rewrite it as a nice little friendlier way here to write it. It's just going to be 6x over 2 minus x squared over 2. So a of x is equal to, and putting it in descending order then, negative x squared over 2 plus 3x. And that's easy to take the derivative. It's tougher to take the derivative of that top one, right? You're going to use the product rule. It's like, really? Don't make it so difficult. So that means a prime of x is equal to negative x plus 3. Okay, so I set that equal to 0. So x equals 3. And then y is equal to, well, actually I need to check it first, right? I need to do my interval testing here. So 3, and then 2 and 4. And if I check that, I get a positive slope here, negative slope, so it definitely is a max. And then I plug it back in, I get 6 minus 3 over 2, so y is equal to 3 halves. Okay, and so that's, I mean, it's nice to have the x and the y, but make sure you answer the question correctly. Determine the length. The length, of course, as I said, is my x value, and the width is my y value. And they have no units, so that's what it is. Okay, and again, do I need to check my endpoints? All right, no, I don't, because why? You can't have a 0 length of a rectangle, because it wouldn't be a rectangle anymore, or a 0 width. Okay, pretty straightforward. Okay, but keep that in your mind. You should always look at the problem and see if you need to check endpoints, because I'll tell you, if there's a problem and there's some sort of endpoint on there and you don't check for it, you're going to lose a point automatically. All right, so always be aware of that. All right, number 4, a rancher. What if he likes ranch dressing? A rancher has 200 feet of fencing with which to enclose 2 adjacent rectangular corrals. What dimensions should be used so that the enclosed area will be a maximum? All right, so this is what the picture looks like. And we have two corrals here. All right, and they're adjacent, touching each other. Basically, what I can do is my distance here. We'll just call this y, and we'll call each of these x. Okay, doesn't really matter. I don't care what variable. You can use length and width is fine. All right, so basically what we do is we have we're looking for a maximum area. So do you guys agree? Area equals x times y. Right? The perimeter is really what you're given because you're given so much length of fencing. So my perimeter is equal to 3x, right? Because it's 3 of the x's and 2 y's. And that, of course, equals 200. So now I have two equations. I'm trying to maximize the area, so of course I'm going to solve for one of the variables so I can plug it back into the area equation. And I'm going to solve for y. I think the reason I'm solving for y here, it doesn't really matter. But one of the reasons is because then I know at least I'm going to lose one fraction, right? 200 divided by 2 as opposed to 200 divided by 3. Then you get two fractions. Doesn't really matter. Anyway, I got 2y is equal to 200 minus 3x. So y is equal to 100 minus 3 halves x. And then I'm going to substitute that into that y there. So I get my a of x is equal to x times 100 minus 3 halves x. So a of x equals, let's put it in descending order. So I get negative 3 halves x squared plus 100x. Okay? And let's take the derivative. So a prime of x is equal to negative 3x. Ooh, that's kind of sweet. Negative 3x plus 100. Set it equal to 0. And I get x equals 100 over 3, which is 33 and a third. Usually when you're doing application problems, just pretty typical in engineering and whatnot, you give it as a mixed number. Because if somebody asks you, well, how many miles is going to, of bridge am I going to have to build? And you say, 13 over 3 miles, they'd be like, what? But if you say, oh, it's, 4 1/3 miles, whatever, then you'd say, oh, okay, I understand that. All right, so just a little tip there. Anyway, that's my x value. Let's do our interval testing. So 33 and a third, and it doesn't really matter. We can pick 30 and 35. Okay, and this is going to be a positive here and a negative here, so this is a maximum. And do I need to do endpoint testing? No, I don't, because why would a rancher want to build a corral with a 0 dimension, right? That would just be like a fence in a random location with no edges at all, just one line. Okay, so you don't need to test interval testing here. So my width I chose as x, so we need to find out the value of y, and it's just going to be 100. We're going to plug it back into this guy right here, right? 100 minus 3 halves times 100 over 3, and you wind up getting y is equal to 50. Okay, and so our answer is the width is 33 and a third. Don't forget your units. You lose a point if you don't have units. And our length is 50 feet. That's it. Okay? Again, no endpoints. Don't have to worry about it. Sometimes you have endpoints with these problems. Okay? But not with that one. All right, move on. An open cylindrical container with a circular base is to hold 64 pi cubic inches of liquid. Find the dimensions so that the amount of metal required to make the vessel is a minimum. Okay, now we're doing a minimum type problem. And, so I can just draw a cylinder here real quickly. It doesn't take very long. Okay, so here's your open cylindrical, and which this you have a couple different things here. You are trying to minimize surface area with that amount of liquid, holding 64 pi inches cubed of liquid. So the volume of a cylinder, if you remember, it's pi r squared, right? It's the area of the base times the height, right? Base area times height. So it's pi r squared h, and that's equal to 64 pi. And then the surface area of this is, first of all, it's an open cylindrical container. So do you guys agree I have one base, which is pi r squared? That's one base. It would be, if it would be a closed cylindrical, it would be 2 pi r squared. So it's pi r squared. And then the area going around, do you guys agree it's just like a big old rectangle? I mean, you can remember the formula, but it's a really big rectangle. And so the length of the rectangle is your h, and what's the distance around, or the length of that rectangle? Isn't that just the same thing as the circumference? And the circumference of a circle is 2 pi r. So it's plus 2 pi r and then h, which is the length of the rectangle. Okay, and you're trying to minimize this. So what I'm going to do is I need to solve here for something and to plug into this equation. All right, this is the deal. I can solve for either h or r. Now to solve for r, that's brutal, guys. You'd have to take the square root. You're plugging in nasty things. Why don't you solve for h? It's so much easier. So we're going to solve for h in this equation, right, in the volume equation. So anyway, if I solve, I move, I divide everything by pi, so the pi's cancel, and I get r squared h equals 64, and so I get h is equal to 64 over r squared. All right, and then I can plug that into my nice little friendly formula here, because I'm trying to minimize that. So my surface area is equal to pi r squared plus 2 pi r times 64 over r squared. Okay, so you get surface area is equal to, simplify that a little bit, pi r squared plus 128 pi over r. Okay, and we'll call that S sub r, surface area. Okay, so then I have S prime of r. Take the derivative, very simple. It's 2 pi r minus, using the quotient rule, 128 pi over r squared. Okay, and so that equals to 0. So I get 2 pi r is equal to 128 pi over r squared. And I got 2 pi r cubed, cross multiply, 2 pi r cubed equals 128 pi. And the pi's cancel out, divide by 2, so I get r cubed equals 64, so r is equal to 4 inches. Okay, and let's do our interval testing here. So 4, and let's put a 3 and a 5 here. So it's negative and positive, so you can use your hand down to up, right? Gives you a minimum, so because we were minimizing our surface area. All right, and so they ask you for the dimensions, so the radius is 4. H is equal to 64 over 4 squared, so we get 64 over 16, which is 4. Okay, so the radius equals 4 inches. The height is equal to 4 inches. And that's your answer. All right. Once again, do I need to check endpoints? Nope, I sure don't, because again, you can't have a dimension of something like this to be 0. Doesn't make sense. So those are our two values. Okay. All right, last problem here. So this is a good revenue type problem, okay, where you try to maximize profit, minimize cost. Anyway, the cost to your small company of manufacturing X units of a certain product is given by C is equal to 2400X minus 5200. The price that you charge your customers for producing one, and notice that is highlighted, is underlined. I'm going to highlight this again. Okay, for producing 1 unit is given by P is equal to 6,000 minus 0.4x squared. How many units should your company manufacture generate maximum profit? What price should you charge per unit? Okay, so profit is equal to what you charge. So let's write this out here. Profit is equal to what you charge minus your cost. Okay, that's important. What you charge minus your cost. So let's kind of write out what these different things are. The first thing they give you is the cost. Okay, the cost is 2,400x minus 5,200. That's the total cost of producing X units. Okay, your charge, how much you're charging, that's equal to 6,000 minus 0.4x squared. Now, notice I highlighted that 1. That's how much you charge for 1 unit. This is the cost. This is the total cost because it already has 2,400x, right? 2,400x. This one is charged for 1 unit. So what you can't have apples and oranges here, even though I like both of them. You have to have the first one's your total cost, and this one I need to rewrite as 6,000 minus 0.4x squared times the number of units. That's important. You will see that a lot. Okay, and you got to multiply it. It might already say for total number of units, and that's fine if it's already in there. But if I just say for 1 unit, you need to make sure you multiply that by x. Do not forget that. That is really important, and people forget that. I'm going to put a couple stars here because people are going to forget that. But maybe if you think of stars, you'll remember it. Okay? All right, so now let's get our profit equation. So P of x is equal to, let's write that, it doesn't really matter, negative 0.4x, but if I can write negative 2/5, it's easier to take the derivative, negative 2/5 x cubed, right, multiplying that out, plus 6,000 x minus 2,400x minus 5,200. So if I simplify this, P of x is equal to negative 2/5 x cubed plus 3,600x plus 5,200. And what are we trying to do with that? We're trying to maximize our profit. So we're going to take the derivative. So P prime of x is equal to negative 6/5 x squared plus 3,600. And we'll set that equal to 0. Okay, and I move that 3,600 over, multiply by negative 5 over 6, and I wind up getting x squared equals 3,000. And take the square root, x equals 54.77. Okay, you can't make 54.77 units. Got to think logically a little bit. If you're talking about distance, that's fine. But if you're talking about units, can't produce that, so we're going to round to 55 units. Okay, let's do our interval testing here. Kind of go back on top here. 55, 54, and 56. And this is going to be positive and negative, so that's going to be a max. Sweet, sweet, sweet. All right, and what do we need to do? Do we need to do any endpoint testing? Actually, we do. Now, we only have one endpoint here because I can keep making more and more and more units, right? So I don't have no endpoint. I have no endpoint going in the positive direction. But what's my lowest endpoint? Do you guys agree it's 0? So I need to check P of 0. Okay, because sometimes it's more profitable. I know it's kind of weird to say, but sometimes it's more profitable to make 0 units. Okay, if the price of a raw material just skyrocketed, you couldn't sell, the people are not going to pay more money for something, and the cost of some steel is a huge amount, you can't make any profit. You actually lose money if you build a product. So sometimes it pays just to not build a product. Maybe you shut your doors for a couple of months while the price of raw material goes down. Okay, I mean, it's not necessarily a good business model, but sometimes that's what it is. All right, so anyway, if I plug in P of 0 into the original equation, I went up getting 5,200, right? Just because everything cancels, so $5,200. But of course, by me plugging in 55 units into the original equation, I get a number of 136,650. Okay, so obviously that's the way to go. Okay, so let's look at what the question asks. It says how many units should they create, and our answer was this one here, 55 units. And then it says what price should you charge per unit. So again, be careful of what they're asking. What price should you charge per unit? Here's the charge, right? And the total charge per unit. So we're plugging it back into this guy right here. 6,000 minus 0.4 times 55 squared. And so we get an answer of $4,790 per unit. Again, don't forget your units. I have units twice, the word unit and the dollar sign. Okay, and that's my answer. So anyway, those are my 6 examples, math fans. Hopefully you need to check for endpoints. Always do your interval testing, very important, and show your work. Don't forget units, and you'll be good to go. All right? That's it, math fans. Have an outstanding day. Adios. Goodbye.